Hey everyone, welcome to another episode of Black Guy Does Physics. Today we're going to be taking a look at a problem that Midnight Shadow, great name by the way, wanted us to knock out. If you have any physics problem that you'd like this black guy to solve, please comment below. Alrighty, let's get it cracking. First things first, we see a diagram. So once we see a diagram, we try to upload concepts to our brain. I see a dude pulling a sled. I've never been sledding or anything like that, but I know he's pulling something. So automatically, forces pop up in my brain. That's the concept I'm going to be working with. Now, side concepts would be energy and motion, but they would have to give you other things. But you know for sure there's forces. Well, once we have done that, let's look at the problem and start reading. A man pulls, there we go, pulls, that means there's forces, a sled up a ramp by means of a rope attached to the front of the sled. The mass of the sled is 80 kilograms. So once again, I write what I have. Kilograms tell me its mass. The coefficient of friction between the sled and the rope is mu is equal to 0.70. So I put mu is equal to 0.70. Remember, this is not friction, it's the coefficient of friction. Okay, friction has a units, newtons. You don't see any units here, then it cannot be a force friction. It's just a coefficient. The angle between the rope and the horizontal is 25 degrees. So I'll call that theta, and that will be 25 degrees. And the angle between the rope and the ramp is 35 degrees. I'll call that alpha, which is 35 degrees. What pull must the man exert to keep the rope sled? So let's call that force P. So we see that this is a force problem. Now, for every single problem, the first thing you have to do is write down what is true once you figured out the concept. So for this particular concept, forces, what is true? We know that F net is equals to MA. But that won't help us too much because that is just a stepping stone for the real fact of F net X is equals to MAX. And F net Y is equals to MAY. Now that I have this, all I have to do is trust the process. Trust the process. All right, so with this, the process is, first things first, draw your X and your Y axis. Since it's on a surface, you're going to make your X and your Y axis along and perpendicular to your surface. So this is my X axis. That's the first thing that we have to do. Make our y-axis perpendicular to that. I'll call up, give it directions, to the right being positive, to the left being negative, down being negative, up being positive. Keep it simple. Now, once you've done that, the next step is to draw your forces. There are 5 different forces that you should know. These are weight, the normal force, which I call Fn, the frictional force, which I call Ff, the tension in a rope, which I call T, and the spring force, which I call F spring. Okay, so once you have a force problem, all you have to do is check to see if you have any of these forces. So let's go to black here and draw. So let's see. Weight, yes, all masses have weight and weight acts straight down. So we do have weight. Hopefully that's straight down. That don't look straight at all. All right, let's see. Go back here and draw this straight. Okay, great. Don't draw your weight to the side, man. It's always straight down. And that's my weight. It's on a surface, so there would be a normal force which is perpendicular to the surface, Fn. It did mention friction. Friction always acts in the opposite direction of motion. So the thing is going up, friction would act to the left, and it's always parallel to the surface. So that's your friction there. And it's pulling with some force P. Great. That's step 2. So we've drawn all our forces. The next thing is to do is to pull down, break down any forces that does not look like your X and your Y. When I look at this, P doesn't look like X or Y, and MG doesn't look like X or Y. So all I do is that I make right triangles out of them. One like this, see that? One line parallel to your X, one line parallel to your y, and you put arrowheads on them. Head to head, tail to tail. So the heads meet and the tails meet. You do the same thing for this one. One parallel to your x, one parallel to your y-axis. Great. Now, this is 35, but there's a trick here to get the angle at MG. If you break this down, in other words, if you put the right triangle by where the angle is, then the bottom is 25. It's just basic geometry. That's something for another day. Just trust me. It's 25 degrees there. Bottom, man. Keep it simple. All right. Now that we have broken it down, you have to use your basic trigonometry to get the sides of the triangles themselves. Now, let's see here. The easy way of remembering this is just simple. You just said the one that touches the angle you're using, it's the cosine. The other one, it's the sine. So if I look at this one is touching the angle. Let's make that into a different color. Let's make it into blue. This one is touching the angle. So if it's touching the angle, that's P cosine of 35, which I call my alpha. And this one is not touching the angle, so it's P sine 35. I do the same thing here. This one is not touching the angle, so that's mg sine 25. And then this one is touching the angle, so it's mg cosine 25. So that are my precursors I do, because I'm just trusting the process. What's the next step in the process? Just follow what the thing says. F net x is equals to max. Oh, I forgot to put that. This thing is accelerating that way. See? Because once you're making any type of motion, the thing is only accelerating in one dimension. So let's go with x first. What does F net x means? Add up everything that looks like x. All the arrows. So here I could see I have this arrow looks like x, this arrow looks like x, and my FF, which is hiding there, looks like f. So I have three forces. So I just add them. And that would be minus FF minus mg cosine 25 plus P cosine 35 equals to max, where ax is just a because that's the acceleration along there. There's only one acceleration. It's either ax is going to be 0 or ay is going to be 0. 9 times out of 10, ay is 0. Now, oh, look at me. I did not see that it said something very important. Moving at a constant velocity. Remember, kids, you have to read through. You have to make sure that you underline and know what you're doing. Don't be a mumu. So here we go. Constant velocity simply means that the acceleration is equal to 0. This is very important for this particular problem. So if that's the case, I see that this boop goes to 0. Almost made a mistake. It's cool. It's cool, man, as long as you catch yourself. And the problem would have told you not that something is off. Yes, you have to finish reading the problem. Now, here I know that there's an equation for my frictional force. There's an equation for this thing. And that equation is mu Fn. So automatically, once I have a mu and I see that I've written down friction, I should change it to mu Fn. Now I could go through and check to see if I know everything here or if there's anything that is missing. I'm looking for P. That's what I'm looking for. I know M, no G, don't know Fn, and I know mu. So that simply means I have to find Fn. Now, I don't go around and be like, oh, where's the formula for Fn? No, I don't do that. I just trust the process. Trust the process. What's the next step in the process? You go to the y, the vertical, and you repeat. You just rinse and repeat, man. F net y, you just add up everything that looks like y, keep it moving. So you could see here, there's this one, this one, this one, 3 of them also in the y. And we just write them down. So Fn is going up, so it's positive P sine 35 is going up, so it is also positive, and mg cosine 25 is going down, so it is negative, and that is also equals to MAY, which AY is 0, so that goes to 0. Okay? All right. So now I check again to see what I'm missing. I'm missing this, I know this. Once again, we do not panic. Never. Okay? We don't become omelets. What we do is that we just follow the procedures that we have. Now, this is what you call a system of equations. I will do a separate video to explain a systems of equation. This is one equation, and this is two equations. What you could do, the shortcut is just simply this. You solve for the thing that you're not looking for, in this case, Fn. Solve for it. Just solve for it. Don't worry about what's going to happen to it. Just solve for it. So let's just solve for it. So that would mean Fn is equal to mg cosine of 25 minus p sine of 35. There. So now you ask yourself, what do I do with this? Well, because Fn is equal to that, I could take it and I could substitute it all the way back here. So let me write that down. I substitute Fn into 1. So wherever I see Fn, I'll do that. I'll put that long thing there. So that gives me mu mg cosine 25. I'm just going to multiply it out. Mu p sine 35 minus mg cosine 25 plus p cosine 35 equal to 0. And at this point in time, some students are getting lost and like, oh my God, it's so long. Don't worry, man. Just follow the process, check the process. I just check again. I know this. So I'm good. So now all I do is just rearrange and solve. If at this particular juncture, you're like, I don't want to rearrange, stuff the numbers in. You can stuff the numbers in and you could solve. But for explanatory reasons, I will rearrange. Hopefully my math doesn't fail me. So you'll have p cosine of 35 minus mu p sine 35 is equal to mg cosine 25 minus mu mg cosine 25. Did I make a mistake? Cosine 25. No, I'm good. Okay, cool. Now I just factor out my p, and that would be p is equal to mg cosine 25 minus mu mg cosine 25 over cosine of 35 minus mu sine 35. And we should be good. Well, there you have it. Another problem smash. Please like, subscribe, comment below, ring the bell. Just ring the bell. And please do remember, kids, don't be a moo-moo.